Yes. Good morning, children. Today we'll learn about the differential equations. This is the last chapter in maths paper 2B. So, what is a differential equation? Before learning about these equations, we'll just recapitulate about the derivatives, product rule, quotient rule. Hmm? Now, suppose that you have any equation like this x square y cube. Hmm? Suppose you have to differentiate this with respect to x. Differentiate this with respect to x. Then how will you do? This is in the form uv. You know that derivative of uv is equal to u into derivative of v d by dx of u v l, right? Suppose that u and v are two functions of x, then d by dx of u v is equal to u into derivative of v plus v into derivative of u, So you have to apply this rule. We'll come across this type of type of derivatives in this chapter. So first exercise is almost deals with the derivatives, and second exercise deals with the integrals. Third exercise onwards, it is deleted for this academic year. Hmm? So we'll just revise these derivatives. You have learned all this in first year. So we need all these things. Derivative of x square y cube. You must use the product rule. So it is equal to first function into derivative of second function plus second function into the derivative of first function. Okay, so now what is it? X square into. Now you must find the derivative with respect to x. It is not the same variable. So you will write its ordinary derivative as 3y square into d by dx of this inner function, that is y. So into d by dx of y plus y square into, now derivative of x square with respect to x. Derivative of x square is 2x. 2x into d by dx of this x, that is 1. So like this we do. So we will simplify. So this is about product rule. Now suppose you have a quotient function like this. Suppose u and v are two functions of x. Then d by dx of u by v is equal to denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. This is the formula. Okay, now suppose you need the derivative of d by dx of some x cube by sine theta, sine y. Suppose I have like this. So how will you do? Here the variables are different and here it is x. So denominator into the derivative of numerator minus numerator into the derivative of denominator, that is sine y, by denominator square. So sine y whole square. Okay, so now what is the derivative of x cube sine y into derivative of x cube is 3x square. 3x square into d by dx of this x, that is 1 minus x cube into derivative of sine y. Derivative of sine y is cos y into d by dx of this inner function, that is y. So d by dx of y. So like this we do the differentiation, sine y whole square. If it is the same variable, you will not write any coefficient. If it is a different variable, you will write its usual derivative and then multiply by d by dx of that variable. So like this we find the derivatives of these functions. Okay, now this is about the quotient rule and product rule. Now we also need a successive differentiation. What is this? You have learned this in last exercise of differentiation chapter. Suppose that I have y is equal to sine square x. Then differentiate with respect to x. Understand this successive differentiation because we need this successive differentiation only in this first exercise part of this chapter. So now differentiate. So differentiating with respect to x means d by dx. So d by dx of y is equal to d by dx of sine square x. Okay. So that means dy by dx. So this is dy by dx. Generally, we denote dy by dx also by y1. Y1 is dy by dx. Okay, now what is the derivative? The inner outer function is square, something square, x square like. So what is the derivative of x square? 2x. So 2 sine x into the derivative of sine x. Now what is the derivative of sine x? So 2 sine x into derivative of sine x is cos x. Cos x into again the derivative of this inner function, that is x. Derivative of x with respect to x is 1 only. So this is 1. So you have like this. Okay, so you can also write this 2 sin x cos x as sine 2x. Okay, so this is y1. Now again differentiate this. Successive differentiation means first time you will differentiate. After getting the first derivative, that again you will differentiate. That means it is again d by dx of y is first derivative. D by dx of dy by dx. So that is denoted by d square y by dx square. So this is the first order derivative. This is the first order derivative. This is the second order derivative. Second time you are differentiating successively. So this is the second order derivative. So it is not that you are multiplying d into d square like that. This is purely a symbol. This is a symbol. So dx square, it is dx square. Like in this notation, it is denoted by y2. So it is equal to d by dx of sine 2x. What is the derivative of, again see, sine x, it is not sine x, sine 2x. So inner function is 2x. So what is the derivative of sine x? Sine x derivative is cos x, cos of 2x into d by dx of the inner function, that is 2x. So derivative of 2x is 2. So it is cos 2x into 2. Into 2 that I'll write here. So this is the second order derivative. Again if you differentiate, differentiating with respect to x, it is d by dx of d square y by dx square. That is denoted by, okay, d by dx of this d square y by dx square is d by dx of 2 cos 2x. Okay, now see this d by dx of d square y by dx square is denoted by d cube y by dx cube. So this is the notation. Again, if you differentiate, it is d power 4 y by dx power 4. Okay, so this is denoted by y3. So it is the derivative of this. So 2 into derivative of cos 2x minus sine 2x into the derivative of 2x. Derivative of 2x is 2. So again another 2. So that becomes minus 4 sine 2x. So this is how we differentiate successively. So all these procedure we need in these problems. Okay, so next is notation is over. Now we'll take one function like this. Suppose I have x square y cube, x square y cube is equal to some t. We'll take this as t. Now differentiate with respect to x. Okay, so that means d by dx of t is equal to d by dx of x square y cube. Try to understand the steps here. So this is dt by dx. So dt by dx is equal to, it is in the form uv. So first function into the derivative of second function plus second function into the derivative of first function. So like this you will write. So it is equal to x square into y cube, derivatives with respect to x. So you will write its ordinary derivative as 3y square into derivative of y into d by dx of y. Okay, plus y cube into derivative of x square 2x into d by dx of x, that is 1. So that means it is equal to x square. Okay, I'll write it as 3x square y square dy by dx I'll write as y1 plus 2xy cube. I'll write like this. So this is dt by dx. Now the next one which I am going to do, that is very important, understand. So d by dx of dt by dx is equal to d by dx of 3x square y square y1 plus d by 2 I can write outside. Here also I can write this 3 outside because it is a constant, plus 2 into d by dx of xy cube. Okay, so you will write like this. Now see, this is nothing but d square t by dx square, that is equal to t 3 into. Now see, this has three functions, x square into y square into y1, x square into y square into y1. So three functions. When it is product of three functions, it is first function, second function into the derivative of third function plus first function derivative of second function into third function plus derivative of first function into y square into y1. So you will have like this, plus 2 into dx into d by dx of y cube plus y cube into d by dx of x, like this. One by one you write here, because here we got three functions, so we are getting it very lengthy, but you won't have such lengthy problems in the exercise. Okay, because we have taken this example, we'll just write the steps, what it is, how it is found. Okay, u v w, so u v into derivative of w plus u into derivative of v into w. One derivative you will write. So like this you will write. So it is equal to 3 into, now see how it is written, y square into derivative of y1. Derivative of y1 is what? y2. Derivative of y1 means what? It is d by dx of dy by dx. y1 means dy by dx. So derivative of y1 is d square y by dx square. So d square y by dx square, that is y2. So directly we'll write derivative of y1 as y2 plus x square into, now derivative of y square is 2y into dy by dx. Only for this it is 2y into dy by dx. So this dy by dx I'll write as y1 into another y1 is there. So it becomes y1 square. So if you could follow all this, then finding the differential equation will become very easy for you. So it is derivative of x square. Derivative of x square is 2x. It is with respect to x only, so 1 into y square y1. So like this you should write. So this part you should understand. Derivative of y1 is y2. Why? Because derivative of y1 means derivative of dy by dx. Derivative of d by dx of y1 means it is d by dx of dy by dx, that is d square y by dx square, that is y2, like that. Similarly here derivative of y square, it is with respect to x. So you will write its ordinary derivative as 2y into d by dx of this inner function, that is y. So dy by dx is nothing but y1. So 2y y1. You should be able to write all this directly. Then it becomes easy for you to find the differential equations. Okay, next is we need okay, all this is we need this differentials also. In application of derivatives chapter, first you have learnt this dy formula. Is suppose that y is equal to f of x is a function then dy is equal to f dash x dx. F dash x dx. That means f dash x is nothing but dy by dx. Dy by dx into dx. So this doesn't mean that you are cancelling dx and all. So this is purely a symbol. So you know this formula. So we call this as differential. It is called as differential. Okay, now we'll come to this differential equation. What is the differential equation? It is an equation. You have learnt about trigonometric equations also. So algebraic equations, you know, x square minus 3x plus 4 is equal to 0. This is an equation. Now trigonometric equations, you know, sine square theta plus minus 2 sine theta minus 2 sine theta plus 1 is equal to 0. Or it may contain cos also, or plus cos theta or something like this is equal to 0. So you have such equation. Equation containing algebraic terms is an algebraic equation. The equation containing trigonometric ratios of sine, cos, tan and all, then it is a trigonometric equation. In the same way, differential equation is an equation which contains the derivatives like dy by dx, d square y by dx square. This is the first order derivative. This is the second order derivative. D cube y by dx cube is the third order derivatives, like that. So if the differential equation, if any equation contains the derivatives of the functions and the differentials dy, dx, like that. So here we call, suppose you have a function as y is equal to f of x. This x is called as the independent variable and y is called as the dependent variable. Y is depending on x. X can take any values. So these are the derivatives of the dependent variable in terms of an independent variable x. And these are the differentials of independent variable, dependent variable, so on. So an equation which contains these derivatives or differentials of the dependent variable with respect to independent variable are called as differential equations. I'll take one example. Say, suppose that you have an equation like this: 3y is equal to 7x into dy by dx plus 5 by dy by dx, like this. So this is a differential equation. It has the derivatives. Now this equation has only first order derivative. So this is called as a first order differential equation. First order means dy by dx only. If it contains d square y by dx square like this, then it is highest order derivative, whatever is occurring in that equation. Then that highest order derivative becomes the order of that differential equation. So you must understand first what is order and what is degree of the differential equation, because only when you know the order and degree, you can solve the equation. There are particular methods, like if it is first order, first degree differential equation, then you must apply some particular method. If it is second order equation, you must apply another method, like that. So understanding the terms, order and degree of a differential equation is very important. So we were just dealing with y is equal to f of x. It has only one independent variable. Suppose I have it as a function x and y. Suppose that z is a function of x and y. So it has two independent variables. X and y are independent variables. Like suppose z is equal to x square y plus xy square. So it depends on, z depends on both x and y. So it is a function of three variables. It has two independent variables x and y and one dependent variable z. So to find the derivatives of this, we use the partial differentiation, and we write as dou z by dou x, dou z by dou y and all that is a different topic, totally different. Now if you have only one independent variable and one dependent variable, and the equation contains one independent and one dependent variable derivatives only, then that differential equation is called as the ordinary differential equation. It is called as a ordinary differential equation. Now we'll write the definition of the differential equation. So the definition is an equation involving one independent variable, an equation involving one independent variable and its derivatives with respect to one independent variable and its derivatives with respect to one independent variable. An equation involving one dependent variable and its derivatives with respect to one independent variable is called as ordinary differential equation. I'll write it capital D, capital E. It means that it is differential equation. You have seen d by dy by dx means x is the independent variable. So derivatives with respect to one independent variable and involving one dependent variable. Y is the dependent variable. Okay, now I'll write some differential equations. First we'll discuss about the order and degree. We'll take one examples and then I'll give you the definition. Suppose I have 3y is equal to 7x into dy by dx plus 5 by dy by dx. Now to find the order is observed as dy by dx. Now it is 1. So in the equation you have highest order derivative as dy by dx. So the order is 1. To find the degree, first you must make the equation free. You must have the equation differentials. Derivatives should be in the numerators. It should be like a polynomial equation in the derivatives. What is a polynomial equation? Suppose that you have a polynomial expression or equation f of x is equal to a0 x power n plus a1 x power n minus 1 plus a2 x to the power n minus 2 like this plus so on an. This is called as a polynomial. When you write is equal to 0, it is a polynomial equation. Like suppose I have x cube minus 3x square plus root 3x minus 2 is equal to 0. This is a polynomial. The powers should be natural numbers. The powers of the variable should be natural numbers. But the coefficients can be irrational numbers or any number. But you cannot have fractional powers for the variable. Then that is the polynomial equation. So in the same way here, you must have the equation. The equation should be written in such a way that the powers, it should be a polynomial equation in the derivatives. So here for polynomial, you cannot have x in the denominator, no? You cannot have x in the denominator. In the same way here, dy by dx should not be there in the denominator. So what you do is, I'll write as y1 and all, then it is easy to simplify. Plus 5 by y1 I'll write. Okay, this implies. Now I'll take LCM and also 3y is equal to 7x y1 square plus 5 by y1. So now take this y1 here. So it is 3y y1 is equal to 7x y1 square plus 5. If I write as a polynomial equation, it is 7x y1 square minus 3y y1 plus 5. So the order of the differential equation is 1 because you have the highest order derivative as dy by dx. So the order is 1. The degree is here, you must consider the highest power of the highest order derivative. So what is the highest power here for y1? Here it is 1 and here it is 2. What is the greatest among these two powers? It is 2. So we'll write order as 1 and the highest power is degree. Degree is equal to 2. Like see, in degree, what is the degree of this term? 3. The degree of this term is 2. The degree of this term is 1. The degree of this term is 0. In the same way here, the degree is the power exponent. And that exponent should not be any fraction. It should be an integer. It should not be any rational number or irrational number like that. So this is how we find the order and degree of a differential equation. Okay, now I'll take another example. Suppose I have the differential equation as dy by dx plus 3x whole to the power 3 by 2. 3 by 2 is equal to x plus 3 into dy by dx. Now see, you have a fractional power for this. So you must remove the fractional power. So what will you do? You will square on both sides. By squaring on both sides, dy by dx plus 3x whole cube is equal to x plus 3 into dy by dx whole square. dy by dx whole square. By squaring, this 2 will go and here you will have square like this. So what happens now? Now when you expand here, it is y1 plus 3x. y1 plus 3x whole cube is equal to x plus 3y1 whole square. So when you expand, you need not actually totally expand it. You can just observe while when you expand a plus b whole cube, a cube. So y1 cube plus something you will get is equal to. And here also x square plus 9y1 square plus 6xy1 like this you will get. So the highest remaining terms also you can write. You can just try. So the highest power of y1 is 3. Here it is 2. Here also you'll get y1 square and all. But the highest power of y1 is 3. So you will write the order is, so the order is 3. Order is 1 because you have dy by dx. First order derivative only. Order is 1 and then degree is 3. Degree is 3. So in the equation, the highest power of the highest order derivative becomes the degree when the equation is made free from radical signs like this. Let's stop. Now we'll take down the write down the definition and few problems as homework. So now this is the first definition. Ordinary differential equation definition. Ordinary differential equation. Next is order of a differential equation is the order of the highest order derivative occurring in it. Next, the degree of a differential. Learn these definitions. The degree of a differential equation is the largest exponent of the highest order derivative occurring in it after the equation has been expressed in a form of a polynomial equation in derivatives. Now, we solved this problem. We have the order as 1 because we have dy by dx. So, here the order is 1 and then the degree is 2. Degree is 2. Just now we have seen. Now, in this case, we have to square on both sides. This power 2 should go to that side. So, in this problem, the order is 1 order because we have dy by dx only. So, it is order is 1. Degree is dy by dx whole cube. The highest power there is 3. So, for this problem, the degree is 3. We have seen. Now, in this case, it is direct problem. You don't have any fractional powers or any exponents in the they are all integers only. So, what is the highest order derivative? D square y by dx square. So, the order is 2. The order is 2. Now, what is the highest power of it? There is only one term, d square y by dx square. We don't have anywhere else. So, the degree of that is 1. Power is 1. So, the degree is 1. Degree of this is 1. So, like this we do. Now, in this case, this is also direct. When you observe, first when you are given the equation, you should observe whether it has any fractional powers like this. When it doesn't have any fractional powers, so for the derivatives, then you can directly write the order and degree. So here the highest order derivative is this d square y by dx square. So the order is 2 and what is the highest power of it? 2 only. Power is 2 degree. So degree of this differential equation is also equal to 2. Now, whereas here you have 1 by 3 as the exponent for the derivative. So, what you should do? You should take this term to this side. So, you will have the equation as y2 whole to the power 1 by 3 is equal to 8 plus 7x y1. Now, this power 3 should go this side. So, you will write y2 is equal to 8 plus 7xy1 whole cube you will write. So what is the highest order derivative? That is second order derivative. So here the order is 2. Order is 2. And what is the highest power of it? 1, because this is lowest order derivative. So the order degree is the power of this y2, that is 1. Now here it is direct. The order is 2 here because you have d square y by dx square. The order is 2 and the highest power for it is 1 only. So the degree is 1. Order is 2 and degree is 1. So you can just try these problems. We'll continue with this in the next period.